Good afternoon, guys. Again, you can see that we're going to go ahead and do a video today of our lesson. I will be back tomorrow to go over the last couple days with you. Before we get started today, I want to read off your homework answers that you should have completed for yesterday. So I'm on page 438 to 439. This will be numbers 10 to 24 even and 54. So I would circle the ones that you might not have gotten correct. That way we can go over them tomorrow. All right, number 10. The exponential form is 9 squared equals 81. Number 12, 10 to the negative 6th equals 1 over 1 million. Number 14, 8 to the 0 equals 1. Number 16, x to the n equals m. Number 18, log base 2 of 32 equals 5. Number 20, log base 1/2 of 32 equals negative 5. Number 22, ln of e equals 1. And number 24, log base m of n equals 3. And then finally we go to number 54, and you are just supposed to be plugging these into your calculator here. A should be 7.5283, B is negative 2.6679, C is 2.2330, D is 1.8379, E is 27.8934, and F is negative 37.0039. So those are your homework answers from yesterday. Again, any questions you have, we will most certainly go over those tomorrow. All right, let's move into our notes for today. Remember, as we go through this, you can pause, replay, and re-listen to this as much as you might need. Okay, so we're on day 2 here of logarithmic functions. So I'm going to start with this statement. In order for b to the x to equal b to the y. Now, if this is going to be true, I hope the first thing that you notice is that the base is the same for both of these. That is critical. You have to have the same base if you even want these things to begin to be equal. Well, if the bases are the same, then the other thing that we need to know for these things to be equal will be that the exponents have to be the same. Okay, the only way for these two things to be equal is if the bases are the same and the exponents are the same. Okay, so we're going to use that property here to kind of talk about some logs. So it says evaluate. Log base 5 of 125. Now you can see it doesn't equal anything. Okay, so we are going to rewrite this using exponential form, and then we're going to try and solve for x. Well, you might say, first of all, I don't see any x's. Well, normally with logs, we have them equal to something. So we're going to say, let's let this be equal to x. And now let's use your parts of the log to rewrite this. We have 5 to the x equals 125. That's just changing that from logarithmic form to exponential form. Well, now, if I want these things to be equal, they got to have equal bases. Well, I can't change this base of 5 over here. So I need to write 125 as a base of 5. Well, 125 is actually 5 to the 3rd power. Well, my bases are now equal. So therefore, if I want them to be equal, my exponents have to be equal. And therefore, x would have to equal 3. All right, let's try again. If I look over here at number 2, we're going to set this thing equal to x. And now we're going to rewrite it in exponential form. Okay, well, I need to solve for x. I cannot change this base of 3, but I can turn 81 into a base of 3. And 81 is 3 to the 4th. Now, you might be saying, well, how do you know that that's 3 to the 4th? Well, you just have to figure it out, quite honestly. You have to know that I need to make a base 3, and you just need to figure out what power that is to make 81. Now that my bases are equal, my exponents must also be equal, and x is 4. All right, let's try again. Same process. Write it in exponential form. All right, now this looks a little bit different, and that's okay. Well, it's a fraction, okay? I can't change this base of 4, so we're going to keep that. Now, the question is, can I write 64 as a base of 4? Well, of course, the answer is yes. So we're going to keep that 1 up top. 64 is 4 to the third power. Now you'll notice that 4 to the third power is on the bottom. Well, you know from your properties of exponents, if it is on the bottom of a fraction, that means it was a negative exponent. So this is really 4 to the negative third power, meaning we would push that to the bottom and then it would become 1 over 64. So from this, I know that my exponent must be negative 3. All right, let's take a look at number 4 here. We'll set it equal to x. We'll rewrite it in exponential form. Notice I put parentheses around that 1/2 to show that whole fraction is raised to the 1/2 power. Okay, well, I can't really change much about the 1/2, but I do want you to notice that the 2 is on the bottom. Well, if the 2 is on the bottom, that means it was a negative exponent. So this can be rewritten as 2 to the negative 1 to the x power. Well, you know again from your properties of exponents, if I have this exponent outside my parentheses, I am going to be multiplying those exponents. So this is really 2 to the negative x power. All right, now how about the other side? Can I rewrite 8 as a base of 2? Yes, 8 is 2 to the third power. So now that I have this, my bases are equal, well, my exponents also have to be equal. And now to solve for x, we divide by negative 1, and you get that x is negative 3. So you can see this is just a lot of manipulation here. You have to be able to manipulate one side or both sides so that they have the same base. All right, looking at number 5. Well, we have a natural log. Okay, so don't be alarmed by that. I'm going to set it equal to x and rewrite it as an exponent. E to the x equals, now remember your base on ln is e, so that's how I got this e right here, is equal to e to the 6, because that's what we're taking the ln of. Well, the bases are already equal for you, so x will be 6. Let's try another one of those. Let's set this guy equal to x. Remember our base here is e, so I have e to the x equals 1 over e to the third. Well, we're almost in business because we have that e to the third on bottom, which means that must have been a negative exponent. And now I know that x has to be negative 3 for them to be equal. All right, let's get back to some regular logs now. Let's set this equal to x. Let's rewrite this in exponential form. And it looks like that. Well, this is kind of like, what number was that? Number 4, back a ways. I have a 1/2 power raised to the x. Well, that 2 is on the bottom. So that must be a 2 to the negative 1 power to the x. And again, we'll multiply those exponents. So this is 2 to the negative x power. Now, how about that 32? 32 can be rewritten as a base 2. 32 is 2 to the 5th. Now, notice that 2 to the 5th is on the bottom. Therefore, it must have been a negative exponent. And now we're ready with the same basis to set our exponents equal. And when you solve for x, you get x is 5. Okay. Let's take a look at number 8. Don't be alarmed that there's no base here. You should remember from yesterday's lesson that if there's no base, we assume there's a base of 10. So we're going to set this thing equal to x. And we're going to rewrite it in exponential form. All right, well, no fractions this time, but I've got this decimal. Here, I can't change anything about the base of 10, but I can rewrite that decimal as a base of 10. Okay. How many times do you have to move your decimal to make this a base of 10? Well, 1, 2, 3, 4, 5 will help me make this a base of 10. And if you're not really sure, grab your calculator. Okay, this is kind of like back in, I don't know, probably 8th grade or even a little bit as a freshman, you were writing things in scientific notation. Remember how we use 10 to the whatever power? Okay, well, if you look at your calculator and you type in 10, and it looks like I moved that 5 decimal places, 10 to the negative 5th. What is that? 10 to the negative fifth is 0.00001. So this is 10 to the negative fifth. And now we're in business. This is x is negative 5. All right. Let's do 2 more here. Oh, 3 more, excuse me. Let's set this thing equal to x, rewrite it in exponential form, and take a look at what we have here. Now, I can't use my whole fraction technique where I said, okay, if it's in the bottom of a fraction, it must be a negative exponent, because I have numbers in the numerator and the denominator, okay? One of those is not a 1 this time. But if you look at what it equals, over here, I see that this 3, if I square it, I get 9. And this 2, if I square it, I get 4. Well, I want you to notice that the numerator and the denominator are flipped, which means this is going to have to be a negative exponent, okay? And I just said that I squared both of those. So if I change this to the negative 2 power, it should flip it and square it, okay? So that's just a lot of reasoning and thinking about what needs to be done and how those fractions are related. I know you guys don't like those problems, but you got to be able to think abstractly in your head there. All right, let's look at number 10, this time with a red. Set it equal to x, rewrite it in exponential form. Well, speaking of exponents, you know the fifth root is actually the 1/5 power. And now we can set our exponents equal. All right, and last but not least here, let's set this thing equal to x. Let's write this in exponential form. Okay, now first things first, let's get rid of that square root. That is the same as the 1/2 power. Now you'll notice I have 1/5 and the 5 is on the bottom. Well, I need that to be moved up to the top, which means it must have been negative. And now when we multiply our exponents, I get that x is negative 1/2. Okay, so that is just manipulating logarithms into exponential form and then making them the same bases so we can solve for that exponent. Okay, so let's talk about some of these properties now of logs. Now there's going to be a lot of them. Today I'm going to give you 4, and then there's going to be more to come this week. So these are definitely important here. Number 1, I have that the log base b of 1 equals 0. Now, this should be pretty obvious to you, because if you rewrite this in exponential form, you get that. And you know that anything to the 0 power is 1. Okay, so that property should be pretty evident to you. Let's look at number 2. If we do the same thing with number 2 and rewrite this in exponential form, this becomes pretty clear. If I take a base and raise it to the first power, it is just that base, no matter what the number is. 32 to the first is still 32. 47 to the first is still 47. All right, let's take a look at number 3. Again, rewrite this in exponential form. We have the base b to the x power equals b to the x. Well, of course, those two things are equal. So basically, when you see this type of problem, if you have this base equal to this base, the whole log really just equals what that exponent is. Okay, so that base b and that base b basically cancel each other out, and you're only left with x. And finally, this one might look a little strange to you. Okay, that log is in the power. So this right now is written in exponential form. If you change this to logarithmic form, what does it look like? Okay, remember how we have this. We have the log of base b of x equals the power, log base b of x. And this is just from yesterday, how we were turning things from logs to exponents and from exponents to logs. Well, you can see, of course, these two things are equal. So what does this mean? If you have a base b raised to a power of a log of base b, all that you're left with is what you're taking the log of, which is x. So now we're going to use these properties to simplify some logarithmic expressions. All right, so use your properties. Well, if you take a look at this one, this looks very similar to property number 2. Now, if you want to do this algebraically, you set this equal to x, and you write it in exponential form. And it looks like that. Well, if you want this to be true, the answer is 1, which is exactly what property number 2 tells us. Number 2 is going to be very similar. Again, if you want to do this algebraically, you set it equal to x. And remember, the base of ln is e. So this is e to the x equals e. Well, if you want this to be true, x has to be 1. Okay, remember that property. Okay, if you have basically a log of the same base as what you're taking the log of, all you're left with, excuse me, that is not what I wanted to put up there. All you're left with is the power that is on that. So this is the power of 1. Basically, these things cancel, and you're left with that 1. Again, that is property number 2. All right, property number 3. This looks like, this is question number 3, which looks like property number 4. You can see we have the same base raised to the log of the same base. And when that happens, those basically eliminate each other, and you are left with what you're taking the log of, which is 3. Let's look at that again. Here we have a base of e, and ln also has a base of e. So all that we are left with is the 6. They basically eliminate each other. All right, let's take a look at number 5 here. If I set this equal to x, and we do this algebraically, we get pi to the x equals 1. Well, anything raised to the 0 power is the only way you get 1. This looks like property number 1 back up in our list. And again, number 6 is going to be the same way. If I want to have a log of 1, the only way for me to have that happen is have the exponent to be 0. Okay? You can make this algebraic if you'd like, but you will see the only way for that to work is to make the x 0. Number 7 looks like property number 4 again. We have a base of 5. We have a log base of 5. So they will eliminate each other, and all you're left is what you're taking the log of. Okay. Same idea number 8. My log base is the same as my base that we're taking the log of. So they will eliminate each other, and you will be left with radical 2. Now, folks, you can do these algebraically if you want and set them up in exponential form, or you can just know your properties. Remember, if there's no base given, it is base of 10, and here we'll only be left with e. Same idea with number 10. The base is e, this base is e, so all you're left with is a plus b. And last but not least down here, let's throw some more in. Base 5, all you're left with is what you're taking the log of. And if I want to take the log of a 1, no matter what the base, again, if you write this in exponential form, you will see that the only possible way for that to happen is to be an exponent of 0. All right, folks, so we've kind of had 2 days into the introduction of logs. Hopefully this is going okay. If not, please feel free to see me during meeting period, before school, after school, or we will go over them during class tomorrow. So here's your homework that goes with this lesson, and then you will have 2 homework assignments to show me then on Wednesday when I see you. Thanks. Have a great day.